Alright, so let's look at rational functions. Those are ones which can be expressed as the quotient of polynomials, like this. X plus 3 is a polynomial, and 2x squared minus 8 is a polynomial. So this function f of x is the first polynomial divided by the second. And a polynomial, just to review, is the sum of terms with variables raised to the power of 0 or some positive integer. So you can think of this as, so this is 2x squared, so it's a nice positive integer, plus negative 8x to the power of 0, um, etc. So if you've got a polynomial divided by another polynomial, you have a rational function, and this whole denominator business causes some problems for rational functions. For example, look at this one, 2x plus 3 over x minus 2. It's going along, and then what the heck is this crazy thing? This line should not be there. That is not part of the graph. And the grapher that I used got confused at this point. When x is 2, the grapher got very confused and did this crazy vertical line, which isn't really part of the graph. And then after it got past that weird point, it kept on going normally. Why is that? Well, basically because you can't divide by 0. The value of a function um, when something is being divided by 0 is undefined. So this function is actually undefined when x is 2. It's defined everywhere else, but not when x is 2. Why would that be? Well, if you look at the denominator of this rational function, x minus 2, when is that denominator equal to 0? When x is 2, the denominator is 0 for this rational function. Well, if you have a denominator of 0, that's undefined. You can't do that. That doesn't mean anything in math. So this function is undefined at x equals 2. So that's the key for finding the domain of a rational function. It's figuring out when is the denominator 0, and then the domain does not include that point or points, right? So normally a function, we could say typically a function would have a domain of all real numbers, and anything that's a real number would count, from to positive infinity to negative infinity. Any real number along that number line would count within the domain of a function. But sometimes certain numbers are not within the domain. So for rational functions, the key is figuring out when does the denominator equal 0, at what value of x will the denominator be 0, and that's where the function will be undefined. So the domain would not include that value or values. So for this function, the domain would be all real numbers except for 2. So a short way of saying that is x not equal to 2. The domain of this function is all real numbers, but x is not equal to 2. So let's practice with these rational functions here, and we could write out their domains. So for this one, so the question, all we need to worry about is when is the denominator 0? When is the function undefined? So we can set 3x equal to 0. Okay, so the domain, so when x is 0, the denominator of this rational function is 0. So the domain would be x not equal to 0, which is a short way of saying all real numbers except where x is 0. Now you might think well, you could factor out an x here, right? See how each one of these terms has an x in common? So we could factor out x out of the top. So x times 2x is 2x squared. X times 1 is x. Oops. get 1. And then x times 3 is 3x. And then you could factor out those two x's, and then all of a sudden we just have the number 3 in the denominator, which will never equal 0. So you might think, oh, all real numbers. Okay, don't do that. The function is this. This is another way of writing that, but it doesn't mean the exact same thing. The function is this, and the function cannot take the number 0. Alright? You can do some factoring to figure out some other things, but don't be tricked into thinking that just because you can cancel out a factor there, and then there's no possibility of the denominator after it's been simplified being 0. Don't fall into that trap. Okay? So just take the denominator as is, and then set it equal to 0, and figure out what values of x will make that denominator 0, which will tell you at what points, if any, is the function undefined. Okay? Let's check out this one. Y equals 10 minus 7x over x squared plus 5x plus 6. So we want to set the denominator equal to 0 to see if there's any points at which this thing breaks down and explodes. Okay, so we have a little quadratic equation here. So we could factor, so we want to know when is x 0. So we could factor this into x plus 3. Now here, we're factoring for the purpose of figuring out at what values this is equal to 0. So it's okay to factor if you need to factor in order to get some information, but don't lose sight of the fact of the original function. So if we were to factor this, x times x is x squared, x times 2 is 2x, 3 times x is 3x, 3x plus 2x is 5x, 3 times 2 is 6. Okay, so we could set each one of these equal to 0, and then so when x is negative 3, or x is negative 2, then the denominator is 0, has a value of 0, so the function is not defined there. So our domain would be all real numbers, but x is not equal to negative 3 or negative 2. Okay, all other real numbers are fine. All right. So let's do the last one here. So 5x over 3x squared plus 9. So let's figure out when the denominator is 0. So we could solve for x here. So we got 3x squared. Sorry about that, 3 equals negative 9. Divide by 3, let's say. So x squared equals negative 3. Now, there's no real number that if you were to square it, you'd get a negative number, right? So like negative 2 times negative 2 is positive 4, right? Or in other words, you can't take the square root of a negative number to figure out what x is. Or, or you can, but the number is an imaginary number, right? So the values of x at which the denominator would be 0 are imaginary, so you can disregard that. Don't worry about that. So the domain here would be all real numbers. All real numbers. So I gave you that as a little example of don't lose sight of the fact that, maybe the domain really is all real numbers. And that's, that would be true for a lot of functions. So all real numbers here. So don't worry about these imaginary numbers. Right. So, okay. So that's brief intro in defining the domain of rational functions and what rational functions are. And yeah, good luck.